This video will be looking at the Cameroon General Certificate of Education 2020 proposed solution, pure mathematics with statistics, paper 3, question 3. The question is on the Poisson distribution. The mean number of goals scored per match by a certain football team is 1.5. Calculate to 4 decimal places the probability that the team will score no goal in the match. Now, in this question, we have to understand it and know what distribution we are going to use. But since we have only one parameter, which is 1.5, then we can start thinking about the Poisson distribution. And of course, it is the mean number. It means that the average of a particular quantity is given. So let me let x to be the random variable for the mean number of goals per match. This means x follows a Poisson distribution where the parameter is 1.5. Here, lambda is equal to 1.5. Since we were told in the question that the mean number of goals scored per match means that the number of matches is equal to 1. So lambda can be written as 1.5 times n. So if the number of matches now moves up to 2, then lambda will be 1.5 times 2, which is 3. Here, n is the number of matches. Now, the probability distribution function for a Poisson distribution is P of x equals to x is equals to e raised to the power negative lambda raised to the power x divided by x factorial, where x starts from 0, 1, 2, and so on and so forth. Because these are discrete random variable, it only takes countable numbers. Lambda is a parameter, of course, and x the number of occurrences. Now, the first question, we were told that what is the probability that no goal is scored in that one match? So I'm looking for the probability of x equals to 0. I come to the distribution and I substitute x with 0 and lambda with 1.5, and I'll get e raised to the power negative 1.5 times 1.5 raised to the power 0 divided by 0 factorial. Now 1.5 to the power 0 is 1 and 0 factorial is 1. So all of this boils down to 1, and I'm left with e raised to the power negative 1.5. And punching this quantity on the calculator gives me 0.2231. So this is the probability that no goal is scored in that match. Now the B part say not more than 3 goals are scored in the match. So from the Poisson cumulative distribution, I'm looking for the probability that x is less than or equal to 3. So let me go to the table and show you how to obtain it. So this is the Poisson cumulative distribution function. And in the question we're solving, the value of lambda was 1.5 and the occurrences was 3. So I follow this row and moves up to 1.5. And so here is our probability. So the probability is 0.9344. So the probability is 0.9344. Now the C part, I'm looking for the probability that less than 3 goals are scored in 2 matches. Now I will let y to be the random variable for the number or the mean number of goals scored in 2 matches. Then remember, we said lambda can be written as 1.5 times n. So in this case, the number of matches now is 2. So lambda becomes 1.5 times 2, which is 3. Now I'm looking for the probability that not more than 3 goals are scored in 2 matches. So the probability that y is strictly less than 3, since y is a discrete random variable, a number strictly less than 3 should be 2. So I'm looking for the probability that y is strictly less than or equal to 2. So I'll return back to the Poisson cumulative distribution, and I'm looking for the probability that y is less than or equal to 2. So back to the table, the new value of lambda is 3. I am looking for the cumulative distribution when x is equal to 2. So I follow this row up to 3, and the value of that probability is 0.4232. So that means the probability that y is less than or equal to 2 is equal to 0.4232. Now the D part of the question is, the team is to play n matches. Find the least value of n if the probability that the team is to score at least 1 goal is to be more than 0.95. So we have some keyword here. The keyword here is that I'm looking for the least value of n, the least value of n, if the probability that the team is to score at least one goal is greater than 0.95. So those are the keywords that we need to take them very seriously. And so I will let x to be the random variable for the number of goals scored in n matches. Then lambda will be equals to 1.5 times n. Remember, n is the number of matches. So to find the number of matches, I have to look for the new value of lambda and then divide by 1.5. But in the question, we were told that the probability that at least one goal, so the probability of x being greater or equals to 1, is more than 0.95, strictly greater than 0.95. So from complementary probability, the probability that x is greater or equal to a is equals to 1 minus the probability that x is strictly less than a. So I can use complementary, the idea of complementary probability here, and I'll be having 1 minus the probability that x is strictly less than 1 is greater than 0.95. And of course, I can subtract 1 from both sides and I have negative p of x strictly less than 1 is greater than negative 0.05. So at this point, I'm dividing both sides by a negative sign, and so this inequality sign will change. So I have p of x strictly less than 1 is now less than 0.05. Notice that the sign has changed. Now, since x is a discrete random variable, a number strictly less than 1 should be 0. So I'm looking for the probability of x equals to 0 is strictly less than 0.05. So I'll apply this to the Poisson distribution and substitute it in its PDF. So I'll have e raised to the power negative lambda, lambda raised to the power 0 over 0 factorial is strictly less than 0.05. Now at this point, 0 factorial is 1, lambda raised to the power 0 as well is 1. So I'm left with e raised to the power negative lambda is strictly less than 0.05. So I'll take natural logarithm of both sides, and I have ln e raised to the power negative lambda is strictly less than ln of 0.05. And this gives me negative lambda because the inverse of e is ln is equals to negative 2.9957. So, and now we are going to solve that, and then we have lambda is strictly greater than 2.9957 because again we have multiplied both sides by negative 1 and the inequality sign has to change. Remember, we were told that lambda is equals to 1.5 times n. We know this. So to obtain the value of n, we have to divide lambda by 1.5. So lambda is equals to 1.5 times n. This means n is equals to lambda divided by 1.5. So I would say n will be equals to the value of lambda is 2.9957 divided by 1.5. Doing the math gives you n as 2. Therefore, the least number of matches of n is equals to 2. So we have come to the end of the solution. But if you do have any questions or any doubt, please leave it in the comment section below. If there are any criticisms, appreciation, or correction, feel free to also leave it down there in the comment section. So until then, have a splendid day, and I will see you in the next video.